Google just dropped Gemini 3.1 Pro, and in today's video I'm going to talk about three important features which will blow your mind. Thinking level parameters, context catching, and how you can create your custom tools using Gemini 3.1 Pro APIs. Hey everyone, this is Sudipta from Technical Potpourri and welcome to my new video. Gemini 3.0 Pro preview was released on February 19, 2026. It is Google's most advanced reasoning model right now and it is required upgrade. Gemini 3 Pro preview is completely shut down. So 3.1 is the correct path. Here it what makes 3.1 different from 3 Pro. Smarter reasoning. ERC AGI 2 scored 77.1%, which is more than double Gemini 3 Pro score on the new logic pattern. Thinking level API, new medium options added. Token efficiency, more efficient thinking across all use cases. Same quality, fewer output tokens burned. And the fourth one, agentic improvement. Better SWE benchmark, stronger finance spreadsheet automation, custom tools endpoint. The 1 million token context window is still there. All right, let's get it connected. So let me first show you how you can set up Gemini 3.1 Pro. So the first thing that you need to do, you need to go to aistudio.google.com, and once you go there, you need to click on Get API Key, and then you need to create your own API key by clicking on the Create API Key button. So I already have my API key created, and this is the one, this is the API key. So I'm going to click on that to copy the API key because I'm going to use that very soon. So with that, I'm going to create a folder, Gemini 3.1 deep drive, and the folder created. So I'm going to go inside to that folder. Once this is done, I am going to create the virtual environment for Python. And the virtual environment is ready. Once this is done, I am going to activate the virtual environment. And the command for this is this one. Once the virtual environment is done, then what I am going to do, I am going to install Google Gemini and python.env. So the command for that is this one. Looks like everything is being installed correctly. So once everything is installed correctly, all I'm going to do, I'm going to create a .env file. So for that, I'm going to use the touch command, touch.env file. And then the env file is created. Now this is the moment when I am going to open this one inside my Visual Studio Code. So let me open my Visual Studio Code. As you can see here, I have a virtual environment. I have .env file. Let me initialize the terminal. So terminal looks good. So let me open this env file, and this is a place where I'm going to store my Gemini API key. So it will be stored inside this variable. I've already copied my API key into the clipboard and I'm going to paste that here. So once my API key is created, the first thing that I'm going to do, I'm going to test the connectivity. So for that, I'm going to create a Python file. So let me do that here. And this is the Python file that I'm going to create. Connection check. Currently everything is empty and I'm going to put that code here. Whatever I am showing today, all the code is being committed inside this repository called Gemini 3.1 Pro API deep drive. I'll put the link of this repo in the description of this video, so you can definitely go and check that out. This is the code that I've copied and I am going to put that inside here. So this is done. With that, I am going to run my Python program to check the connectivity. And look what this is doing. It is using this genai.client method. And here API key I'm getting from the Gemini API key. Gemini API key is stored inside this .env file. And inside this, there is a variable called Gemini API key, which stores actual API key. This API key is being used to get the client, and that is being stored here. And then I'm using this client to get the response, where the model is this one. And this is the content which I'm passing, say hello in 5 different languages. And then I'm finally printing the response. So let's execute this Python file. Looks like it is doing the execution right now. And very soon we'll find, yep, here are 5 different languages in which the hello is being said. Like in Spanish, this is the way, French, Japanese, German, and Italian. So these are the 5 different languages how to say hello. Okay, with that, we have proved that our connectivity is working fine. With that, it's time to move to the first feature. So the first feature which I am going to talk is none other than the thinking level API. So in Gemini 2.5 Pro, you control thinking with a thinking budget integer, which value ranges from 0 to 24576. But in Gemini 3.1 Pro, Google introduces a much cleaner approach, enum. So now we have three different enums for three different thinking level. Medium is a new addition in 3.1. It gives you a middle ground between the speed and the depth that wasn't there before. So here is a full breakdown. Low, which means it minimizes the latency and the cost. So this is based for the simple instruction following or chat. So token mapping is between 1 to 1000. Then comes the medium, a balance between reasoning depth and latency. Maps to the token between 1000 to 16,384. And the last one is a high, is the default one. It maximizes reasoning depth. The model may take significantly longer to reach a fast token, but the output will be more thorough. Maps to token budget between 16,384 and 32,768. So a couple of things to understand. If thinking level is not specified, then the model defaults to high. Setting a token budget to 0 will result in an error. So you cannot set the token budget to 0. You cannot use both thinking level and legacy thinking budget parameter in the same request. Doing so will return you a 400 error. And thinking cannot be turned off for Gemini 3.1 Pro users. So with that, it's time to create our next Python program. So I'm going to create this Python program, thinkinglevel.py, and I'm going to copy the code which I have already committed inside my Git repo and put it here. So let me go through the code. The first part is basically the same, is basically doing the connectivity. Here is a problem. What is the problem? A startup has 3 engineers. Each can build a feature in 6 days working alone. They need to build 5 features. Feature 3 and 4 cannot start until feature 2 is complete. Feature 5 requires feature 1 and 4 to be done. What is the minimum number of days to ship all the 5 features? Assume engineers can split tasks across days and work in parallel. Okay, so that's the problem I want Gemini 3.1 Pro model to solve. So here is the model. With that, this is the response. Here I choose the model. Here in the content, I put it's a hard problem. So in the config, here I am setting the thinking level, and I am telling the thinking level as, because low will be used for faster and lower latency responses. And then I am printing that response here. Okay, let's save that. And this low is basically the enum which comes from types. And this is where I have imported types from Google Gemini. I have imported types. So inside types, we have thinking level, and then we have 3 different enum: low, medium, and high. So here I'm using the low. Okay, so with that, let's execute this program, which is thinkinglevel.py, and let's see what the output is. This Gemini 3.1 is giving me back. So it started executing the Python program, and let's see. Okay, looks like there are 5 features in total. Okay, since there are three engineers in parallel, it is checking the dependencies, which is a critical path. The long sequence dependencies is this, and then finally example of 10-day schedule and this, and then finally conclusion is the minimum number of days to ship all 5 features is 10 days. And how it came to the 10 days, that is exactly, it is being explained here. So this is the way how you should use the thinking level parameter inside Gemini 3.1 Pro. Okay, with that, it's time to move to the next feature, which is context caching. So this is a feature that can cut your API bill up to 75% if you are building the right kind of app. Let's understand a problem. You have a massive document, a legal contract, an entire code base, or a 200-page report, and you want to ask it 20 questions. Without caching, you resend the entire document 20 times. Full input token price every single time. But with context caching, you upload the document once, get a cache ID, and your 20 queries only send the question. The document tokens are served from cache at a fraction of the cost. So you're basically reducing your API bill cost almost like 75%. So with that, it's time to write a Python program to understand this new feature. Okay, so what I'm going to do, I'm going to create a Python program, and it's called cached content.py. Currently it's empty, so I'm going to put the code which I have already committed in my Git repo. So here is the code. And let me explain the code first. First few lines are basically setting up the connectivity. This is a PDF. It's basically my own resume, and I stored the resume inside here. And this is the resume which I also have here. Now what I'm doing, I am first opening this one. Retrieve and upload the PDF using the file API. So what I'm doing, I'm retrieving this PDF and uploading that. Once the upload is done, I'm using the Gemini 3.1 Pro, and here I'm putting a system instruction, which is basically you are an expert analyzing the resume. So here I'm creating the cached content object. This is very important. So the comment for that is client cache create. Model is basically this model name, and in the config I'm creating types.create cache content config, and two parameters which I'm passing is a system instruction, which is basically this one, and the content is nothing but this document. So if I pass that, then it will create a cache content object which is getting stored inside this cache variable. Okay, and I'm printing that. That's okay. But then I'm using this cache content to pass a prompt using this model and get a response back. So here what I am doing, I'm using this model, and the content which I'm passing is basically, please summarize the key technical expertise of the candidate. Here in the config, I'm telling from where you'll fetch that information. You'll fetch that information from this cache.name. This is where you will fetch that information. And then here we are printing the response. Now I'm going to execute that. Okay, it's doing something. Looks like response came back, and based on the provided resume, Sudipta Dev is this. Here is a summary of his key technical expertise categorized by domains: Salesforce ecosystem, artificial intelligence, machine learning, data science, Google Cloud Platform, enterprise architecture, integration and security, functional software engineering. Once I have my cached content object is ready, I can use that when sending a prompt to the model. I don't need to send this entire object every time. That definitely reduces API cost. So that's what this feature is all about. This feature, if used properly, is going to reduce your API cost definitely by 75%. A very important feature that came live along with Gemini 3.1 Pro. I hope you'll definitely take advantage of this one. With that, it's time to move to my last important feature, which is creating your own custom tool using Gemini 3.1 Pro. So in Gemini 3.1 Pro, there is a second endpoint, which is Gemini 3.1 Pro Preview Custom Tools. It's optimized specifically for agentic workflows where you are defining your own tools. For example, view file, search code, review code, do commit, something like that. So it's time to create another Python program to create our own custom tool. For that, I'm going to create a Python program, which is customtool.py, and here is a customtool.py. Currently is empty, and I'm going to copy paste the code from my repo. Here is the code. So let me explain the code first. So first few line again is the same thing. Only difference is this is a new model. In all the previous one, I have used this model, Gemini 3.1 Pro Preview. But here I'm using Gemini 3.1 Pro Preview Custom Tools. So this is something that you need to understand. If you are creating a custom tool, then your model should be this one, not the other one. So here I am basically creating 4 different tools. The first tool is all about to analyze the code complexity, and this is the function. For each tool, there is a function. Second tool is check code patterns. So this is the function. Third tool is basically the check security vulnerability. So this is a function, and these are the different security checks that it will do, and these are the comments it will run. Fourth one is basically check performance improvement. So these are the 4 different functions for 4 different tools. Once this is done, then I'm doing the tool declaration. Here I'm doing the first tool declaration. This is a description and this is a parameter. So inside the parameter, I'm putting the code, I'm putting the language, source code to analyze, and then parameters and description. Second one is another one, which is check code patterns. Third one is a check security vulnerability, and the fourth one is a suggest performance improvement. So this is the way I have declared all the tools. Once the tools are declared, I am basically creating a map function names which will be called by the Python. Now here comes the agentic tool calling loop. This is important. So here I am basically calling the different tools. First, review code with Gemini. What I'm telling, this is basically a description. Here is a system prompt and here is a user prompt. And then these are all the conversation history and everything. Now, important thing, here is a sample code against which I will run all the different tools. So this is a sample code. Now here what I'm doing is that I am review code with Gemini. I'm calling this function where I'm passing this sample code and the language as Python. So this is a function which is stored here. And this is the system prompt. This is a user prompt. It will go through the code that is being passed to that using the model. And model will come from here. This is a model. Okay, looks good. And then it will go through that and give the response back. Okay, so I think it's good to execute this program now. So for that, I am going to first let me clear that. And now I am going to execute this program, which is customtool.py. So reviewing the Python code with Gemini, this is the model. Very soon it will give me the response back. Okay. So as you can see, these are the 4 tools that I have created, and it called basically 4 tools: analyze code complexity, code pattern, security vulnerability, and suggest performance improvement. So all the 4 tools are being called, and now the response from each 4 tools will come back here. Gemini code review report. So it gave the full review. Here is a security vulnerability report. Here is a code quality and anti-patterns. Here is a performance optimization. Here is a refactor code example that is also being given. So looks like I have built my own custom tool using Gemini 3.1 Pro Preview custom tool model. So this is a very powerful enhancement that came along with Gemini 3.1 Pro release. And that's it, Gemini 3.1 Pro. 3 very important features: thinking level, context caching, and your own custom tool to do the job that you want. And if you think this video is helpful, please hit the like icon and please subscribe to my channel Technical Potpourri. And don't forget to click on the bell icon, because next time when I'll publish videos on Gemini or any other AI topic, I want you to be notified first. And drop a comment, what would you build with Gemini 3.1 Pro? I read every single comment. Again, this is Sudipta from Technical Potpourri. I'll see you all in my next video.